Okay, here we go with the bridge rectifier. We're going to go ahead and wire the circuit now. I've gone ahead and calculated my capacitor value, and I've rounded up the next size up, standard size, which is 270 microfarads, and we're going to go ahead and rewire the circuit. Now, for this case, we're going to use both taps of this transformer here and leave the center as ground. So let's first go ahead and wire up that. So we're going to use a red wire to come off of this hot lead and run that to the board. Oops. Okay, to the plus side. Although plus and minus doesn't really matter when you're dealing with strictly AC. We're going to use another red wire for the other AC and connect that to here. Okay. And we're going to use a black wire to be our center ground reference, like so. And then again, tuck that in there and run it to here. So let's leave the channel 1 probe on one side of the positive so we can measure the AC. And then we're still going to ground the probe to the center ground here. Okay. And then this is our bridge rectifier, and you can see there are 4 leads coming out, and they're nicely labeled plus, AC, AC, and minus. So those correspond to the pins that were used up there, and we're just going to plug that into a convenient location on the breadboard. So let's connect the plus up to here, and AC into there. And then the minus, we're going to go ahead and connect just out here off to the side. So the AC, oops, that's wrong. We want to connect the AC one up to there. Okay. So AC, one lead is connected to the upper bus. The other lead, we're going to jumper down to the lower bus. And then these are our outputs. Our plus is red and our minus in black. Outputs. Okay. So those are going to represent our DC output, hopefully in the neighborhood of 5-6 volts, but we'll see what we get. And so we need a jumper. We happen to have one right here. Should work. We're going to jumper the other AC terminal. Oh, I don't think that's going to read. Let's just run this up to here. We're jumpering the other AC terminal to the other AC lead. We'll have to remember to put this back when we're done. Do these have through holes on them? Yes. Okay. So our 2 AC leads are coming in through there. Okay, there, and then those are our DC outputs here. So let us go ahead and put our load resistor between the red and the black. Okay, and then we can put our capacitor. Again, we have the negative sign. The polarity of these capacitors are polarized. So again, we want to put the capacitor on there between the red and the black across the resistor. Okay, so that should be it. It should be ready to go. So let's turn the variac down, turn the power on, and we're going to use this probe here to put it on the positive output. And we don't have to ground this probe because that probe is already grounded, so we can just detach that lead for now. And we chose the bridge instead of doing these 4 diodes just because it's less poking holes in the board. So we can go ahead and turn this up until we get 12 volts peak to peak on channel 1.
Yep, averaging still on.
Okay, so it's slowing it down. Let's temporarily shut off the averaging, acquire, average, off. And we can turn these vertical scales down. And so now we have channel 1, frequency 60 hertz, that's good. Peak to peak is 11 volts. So let's crank this up until we get to 12 volts peak to peak. You could also do this with a meter. It'd probably be more precise. Okay, so now we have 12 volts peak to peak on channel 1, and we have our input is set to the right side, the right amplitude. And what we can kind of see is the humpiness on channel 2. Let's temporarily unplug the filter capacitor. And so what we see is the humps coming up twice per cycle instead of just once. And that is what we're expecting to see. Okay? And there is going to be a little bit of a difference here, just like from there to there be a little bit of a difference as well. So now let's go ahead and put the capacitor back in and see what kind of a DC voltage we get, and we'll see what kind of a ripple we get. All right, so we've got our bridge rectifier built, and we're going to measure the DC voltage coming out. And this time I thought we would use a handheld meter. 1, because it floats, and 2, because it gives you digital accuracy. The scope is not quite as accurate for measuring these. So I'm going to turn this on and set this for DC volts. And we're going to put it on the output. Remember, we're expecting to get about 10.6. And we're actually getting is at about 11.1 volts DC. So we're getting a little more than we bargained for. It could be that this voltage is a little bit high in the first place. It could be that our diodes are not giving a full 0.7 of a volt drop. So, and that is likely because we're not putting a whole lot of current through them. And then here you can see in the waveform, we have the scope set up with a mathematical measurement. So this red here is channel 1 minus channel 2. And we had to do it that way because the ground was a little something funky on this board. So we've taken the difference between the two outputs to measure this. And this is, we set up for a peak reading on there, and it's giving us a peak of about 70, let's see if I can read that. About 60 millivolts peak to peak on this waveform right here. It's dancing around, but that's typical of what I've seen. So we can take this as our ripple voltage, about 60 millivolts. We can take our DC voltage here, about 11.1 as our DC output. We're expecting 10.6. And that should be all the data that you need for this one here. We're not going to do the conduction angle on this one because the waveform is just too funky. So, but we can do the conduction angle from the half-wave rectifier and it'll still work. So that should be everything you need for experiment number 2.